Hi everyone. In this video, we will do a use case where we will build an MCP server for NGS data quality control. Okay, and then we will connect to that MCP server our cloud desktop, the AI assistant, and using AI assistant we will do the NGS QC analysis. So you can think that we are building an AI assisted NGS quality control workflow kind of thing, right? So that's the main idea behind this. So in the past, so far what we learned, like how to build our own custom MCP server, and also we learned how to connect to an running MCP server. So with this prior knowledge, we will be able to do a very basics, NGS quality control MCP server. Okay, that's very interesting. So let's stay tuned. So the idea is like, so we will use this fast MCP package to create this MCP server. Okay, then we run it via HTTP mode so that my server will run in a URL. And now we can configure the cloud desktop to connect to this MCP server. And once it is connected, we can run the quality control analysis. So for this demo purpose, I have created four tools this for the MCP server, like the run fast QC, unzip the fast QC, and from the report we'll get the parse basic statistics and parse per base sequence quality. Okay, these are the four basic functionality it does. So basically, if you can go to my repository, there if you see the readme, here I have detailed explain like what it does. Like run fast QC will run fast QC on a given fastq file, but it is important that fast QC should be installed locally and it should be available to the path. And I will be using WSL to do, and I have already installed fast QC. And once we install the fast QC, basically fast QC will generate a zip file, right? And then you need to unzip it, and for unzip I'm using some Python package for unzipping. And then once we unzip, it will give us a file in the extracted file. It will give fastqc underscore data.txt file, and which from there we are passing basic statistics, and also we are using per base sequence quality. Also we are parsing. Okay, so basically these are simple Python function, and which will allow us to do a lot of things in this MCP server. So let's go to the code directly. Okay. So we'll go to this fourth code, and this is my simple Python script. Okay, I'll go one by one. So how does it what does it say? So first we need is like MCP server to build. We need the first MCP server. So we imported that. Then I need import OS and subprocess. Subprocess is needed to run the fast QC, and I have imported the zip file to unzip this thing. And this is what we created the first MCP object. So very simple, first MCP, and it gives some name here, NCP NGS QC MCP server. And now this object name is important, so MCP. So now simply I am defining few Python functions. Okay, so let's see what all I have defined over here. So I have defined some 5 Python functions. The first function is the run fast QC. Basically what it tells, like it takes an input file, like by default I'm giving some path, but I know user will give some path, and you will specify the output directory. If it is not specified, it will run in the current working directory. So here the instruction I am given that, hey, run fast QC on the given input file. Argument is what? Input file, output directory. So here I have said that directory to save the fast QC report defaults to the current directory. Okay, I have instruction is given here. And then again the command like runs fast QC and my -o output directory input file. So this is how you can pass each argument in the form of a string and pass as a list, create a command. Okay, so here I'm checking if that file is not there, then it will return the message the input file not present. And also if the output directory user have specified, if it doesn't exist, it will create the output folder. And this is the command for running the fast QC. Okay, so I'm using the subprocess.run and then passing the command, and I'm storing all the output, and any text put on a response I'm just capturing over here. So then if my return code, that means if successfully run, I'm returning a message that fast QC completed successfully here. Otherwise it will return the message that fast QC failed. This is the tool I have defined. So now whenever agent interact, right, it will first come over here. If it file it not, so we are sending the response to the agent that, hey, input file is not present. And if successful run, we are sending a response that completed successfully. Otherwise we are sending a response that it has failed. So now the second step, what we are doing, like unzipping, right? So here the instruction is very important, right? Okay, so here I'm saying that unzip a fast QC zip file. The zip file is created by fast QC, first step, right? Fast QC after running on the input fastq file. it will be created in the output directory specified when running the fast QC. So I'm telling that, because agent will not know, right, where this file will be present. So I'm giving the instruction that, hey, this will be mostly present in the output directory given by the user. Okay, so now basically it's very simple. Zip extract all I'm doing, and finally I'm giving a response that it is extracted. Okay, so in the third thing, basically once extracted, right, so it will give a file fastqc data. It will create an extracted folder. There will be a file called fastqc underscore data.txt. So that's what I'm telling that, hey, in the extracted fastqc report folder, in the extracted folder, there will be a file named called fastqc data.txt. Okay, so parse this function parses the basic statistics section from this file. So I will show you when it runs, right. I will show the file content over there. Yeah, but here, so basically I have to tell that where this file will be present, so that agent will know and it will generate that path and it will send it. And basically this is very simple. What I'm, well, from that output I'm just passing basic statistics, and it will give me some response like basic what is the overall QC summary over here. Okay, and again this function will again it will take the same file. Again I'm telling that in the extracted folder there will be a file called fastqc data.txt, and parses this base sequence quality information from that file. Okay, that's a very simple text file, and it will give me a output like this. What is the overall result, pass or fail, what is the mean base quality, and what is the median base quality. Okay, this is a simple Python function, and you can generate this using this function from taking help from ChatGPT as well. Okay, very simple, but you have to understand the concept, like how I'm defining the functions here and just converting into this decorating using this MCP tool over here, right, mcp.tool. So in the last, I'm telling that again, you parse that file fastqc data.txt file, okay, and then give me all verdict, like because fastqc have many QC module, right? So just I'm giving this function, so where I will tell like, okay, this module pass, this module fail, this module war, like that. Okay, this function does that. Okay, and finally, this block is optional, because as I said, we will not using this mcp.run. We will use fast mcp.run, that command we will do. So perfect. So now this is our MCP server. So now let's run it. Okay. So let me go over this folder over here. This is fourth, right? Okay. So now this is my script is there. And again, as I tell, fastqc I have already installed here. Okay. So it's there in my system. In my system I have installed it. So it's working good. And I have created this fastq file over here. Okay. I just demo file is there. Okay, so now let's launch this server. So how will we launch? So you say fast mcp run, and the script name is what? NGS QC.py, and the MCP is the object name. And then I am telling that what is the mode of transport I will be running. So I will saying that streamable HTTP host 00 port 8082. Okay, so this is let's run this. Let's go with 8084. Okay, so because I think some ports might be running, you can check over which port. So 8083 is running, so let's go with 8084. So what it will do now, it will now create an MCP server. Okay, and then it will keep the URL. So it will now launch this one, and it will host it on this port, and we'll get a path, and then we will have to configure our cloud desktop here using this command. So basically same what we have seen in the previous video, right? Okay, so let the server run. Okay, so cool, I think it has started. So now you see this is running on 8084 port. So this one is running. So what I'll do, go to my cloud desktop settings, and then in the developer I go to the edit config. So I've deleted my previous config, and double click, it will be empty like that. So now what I will do, I'll just copy this command over here, this JSON block. So basically simple, here I'm saying that NGS QC MCP server, this is where my npx command is present in my Windows. See, cloud desktop is running on Windows, right? So that's why I have to give the Windows path over here, and it uses this MCP remote package to connect to my Uniprot MCP server, which is running on 8084 port. Okay, so now yeah, so let's close this one, and then you can simply go to settings, developer, and reload the MCP configuration. So now you see this NGS QC MCP server has started initializing. Meanwhile, you can again go to developer mode and check the MCP log, and ideally it should not give some error, and it should show some NGS QC error, message from the server. So that means it's now running. So better we can check new chart. Hey, what MCP local server you have? Okay, so let's check. So now it will see, it is now I have access to NGS QC MCP server, and I have these 5 tools: run fast QC, unzipping, this one, this one, this one. So can you run a fast QC for we have to give the file, right? So my file is present in this location. Okay, so let's go to fourth one here. This is the file, right? So I can get the path is the first cube. Okay, so now one important thing, like, since my server is running where in my WSL, right? So because I have launched there, so I have to give this path. But if you are running on Windows only, then you have to give the Windows path. Okay, so now can you run fastqc on for this sample? Okay, so now let's see what it happens. So now it will go and it will call that, hey, I want to run fast QC from this MCP server. So see, automatically it created this JSON output structure, right? Input file and output directory is equal to dot. I don't know where it will run. Okay. So fast QC has completed successfully. So let's check where it ran. Yeah, it ran in the same folder here, right? So now you see we got a zip file and an HTML report also we got. Okay, so now in the next step we need to extract it, right? So it is automatically say that the output should include a zip file HTML. So now you do unzip, extract, and so now we'll see that just say one. So that means unzip. Okay, so I'm just giving one option, that means unzip it. So now it will do the unzip. Looking for this fast QC that created. So now it automatically uses his brain, trying to search where this zip file. I don't know why it is doing that. Ideally, see, it is very intelligent, and it is trying to search all the files where it is. It tried to search this one, but it did not get, probably. So somehow it is not able to do that. Okay, so let's call this unzip zip file in. So this is the folder, right? So ideally it should have worked because during my testing it worked. The file generated at so now you see it generated this unzip command, so it will extract it. Good, the file has been now unzipped. Okay, so let's see what happened here. So yeah, I can see this folder generated. You see this you see the folder? Yeah, so if I go to this folder, right, so I have this folder, right? So you will see here the fastqc data.txt file. Okay, so if I open this one, fastqc data.txt file, you will see the file content. So let's say what does this does. Okay, so now it tries to parse basic statistics from this file. So you found this data automatically. So let's run this parse basic statistics. Okay, so excellent. Now it tries to run the other thing. What function it is calling? Parse per base sequence quality function it tries to call. Okay, so now it tries to call the all module verdict. So it's third function. Okay, so again you can allow it. So now the finally it gives me entire summary, right? Okay, like is the file name is this one, total sequences were this one, total base pair, what is that overall per base sequence quality that was fail 1035 like this, and this is the overall verdict. Okay, so this I got from this file. Okay, so this is what the overall basic statistics you got, right? Just remember this number 18357, you will see the same number. 18357, 4.1 million base pair, and 122.2359. So whatever the information was there from this block, I wrote a Python function to extract it, and the same one agent did it. Then I also did this block, second per base sequence quality. Basically, I took this mean and median and take the mean of mean, mean of median, like that. So that's what the second one, it gave that overall status was fail, because you see here it says that this block is fail, you know. So that's what you see, that overall quality status is fail, and mean base quality is this one, and median is this one. And all module verdict means what I did, I just did a grape here. Okay, so basically if I type this one is fail, now the next module was this per sequence quality scores fail, per sequence quality scores fail, right? So you can see that I just did a grep, per base sequence content fail, per base sequence content fail. So like that I wrote a Python function. What it does, like so what it did, like it did parse only the grep one. So I see anything that starts with double arrow, right, greater than. So that's what. So use in short, you can see the beauty of MCP server. So what we did, we converted our very Python function and we packaged it into MCP server and we hosted it. And now we connected this cloud desktop to this MCP server. Now cloud desktop is now able to do locally the QC analysis, right? And it's very intelligent also. It will based on this information, you can further empower this cloud desktop, particularly this cloud AI assistant, to follow this process using a skills. So skills is the next advanced concept, another concept where you document how a fast QC quality should be actually done by an agent. So we document that. So we'll say that, hey, so you run this one, you find all this verdict, at least per base sequence quality should be good, the average should be greater than 30. So whatever the way you analyze as a human, the same way you can document for an agent, and you store in a skills file, and then that will be your agent can follow that skills to do this MCP server. So MCP servers, through that you can provide the tools capabilities, and then you can also provide the skills, separate thing, not an MCP part of, but I'm just telling that tools, MCP, skill, these three, how you can using this play around with all these three to make a very powerful MCP server. Okay, so that's what all about. So in short, the code is very simple. Okay, so I'll just quickly summarize. Just import the package, all the modules, you define Python function and just decorate it. Okay, and then run the server using fast MCP run, right? So this is what I have documented here as well in the code. So you run it, so and then configure your cloud desktop and it will work. Now the same thing you can use, like if you don't want to use cloud desktop, if you want to use OpenAI SDK agent, right? So you can run the same approach, like okay, same code you can use. Instead of this, you can pass 8084. So now your AI agent will be through OpenAI SDK agent. You can now connect to this server. Again, the flexibility of using this is like you can have a, let's say, what is that, multi-agent system. Like you have an MCP server, this NGS QC MCP server, where we have hosted all the tools, right? But again, we can have a dedicated what is that, small agent for let's say QC analysis. We can have, let's say, you can add few more tools for, let's say, pre-processing, like which will use Stream Galore to process it. And we can also have some tools for BAM alignment, then alignment QC. So like that, you can have multiple tools, write it, and you can post it into a way, let's say, NGS analysis MCP server. So now this server has many tools. Some set of tools are the QC tools. Some set of tools are alignment tools. Some set of tools are alignment QC tools. So now you can have a multi-agent system where your main agent will take the first Q file and it will call your, let's say, QC agent. That QC agent is equipped with NGS QC, the first QC one. After that, it will call your trimming agent, which will run the trimming. Next, it will call to, let's say, the third kind of agent, let's say BAM alignment agent, who is very expert in alignment. And all these three sub agents, they are all connected to the same MCP server, but they will use different tools depending on their expertise. So this kind of very nice complex architecture also we can create. Maybe in future, and think I can, if I get time, I'll generate this kind of complex MCP. One MCP server with many tools, and like we can have a multi-agent system to do entire NGS analysis by themselves. So the beauty is like once we connect to this cloud desktop kind, right, you can just chat with this interface and you do it. And also, let's say if you want to redo something, right, you can directly ask it. So that's what is different from your traditional pipeline, because in the traditional pipeline we have 1, 2, 3, 4. Okay, steps are there, means always it will go this way. But here endless possibility. You can do 1, 2, 3, 4, then again come back 2, 3, 4, or you again come to 3, 4. So you have all flexibilities there that will be handled by the AI agent itself. I hope this video gave you some perspective, like how to use the custom MCP server, and this is an interesting use case in the bioinformatics domain that might have given you some idea. So next we will talk about how to, so we have built this server, so let's package it into form of a Docker file. Okay, so that we build a Docker, and then you can take this Docker and you can use platform independent. You can host it in a batch job. You can AWS batch job, you can run it anywhere, right, because it's a Docker. So that's what we will see in the next video. I hope this use case was useful, and yeah, I will see you in the next video. Thank you. Thanks for watching.